But I'm going to go ahead and explain it like I didn't go over it yesterday. There are going to be certain elements when you write by themselves, okay? So if you write certain elements by themselves, like these are called the genuine elements. And the genuine just tells you that if they end in gen, or they end in ine, they're going to be diatomic when you write them out by themselves. Okay? So these are called the diatomic or genuine elements. And anytime you write these out, you have to pair them up. Okay? So this is a key if they end in gen or ine. So if they end in gen or ine, they're going to be diatomic when you write them out. So tell me some elements that would fit in that category according to the periodic table.
Oxygen.
Okay, oxygen. So oxygen automatically when it's by itself. Now, if it's with some other element, that is not the case. So to say, I've got to write a 2 every time oxygen appears. No, that's not what we're saying. Yes? Okay. Yep, iodine.
Chlorine.
Chlorine. So really, all of that group 17 on down, because they all end in ine. Okay. So any other gens? Hydrogen, every time you write hydrogen gas, and it says hydrogen gas, you write H2. You don't write H. Okay? And then there's one more. Nitrogen. And if you count them, they're 7. If you count the letters in genuine, they're 7. Okay? It kind of forms a 7. Except for the 7th is over here, H. So nitrogen, oxygen, fluorine, chlorine, bromine, iodine forms a 7. So any way that you can remember that when you do, reactions are important. Everything else, if they're by themselves, you just write one of them. So anything else I have written out, carbon, aluminum, magnesium, any of those. If I write them out and they're by themselves, they just say aluminum metal. Or they, it says a strip of magnesium. You just write Mg or you write Fe. You don't write a 2 with it, okay? That's what we got to make sure that we're doing that during that process, okay? So if that's in your notes, we're going to look at this problem here, and we're going to attempt to do it. So it says when chlorine gas, that's a reactant. Chlorine reacts with aluminum fluoride. The new products formed are aluminum chloride and fluorine gas. So we have an arrow that represents yields or makes, and then our products are over here, and our reactants are here on the left. So how should I represent chlorine gas in my equation? Cl2. Plus. Plus just separates your reactants and products. Plus what? What's it react with?
AlF3.
Yep. So Al, when we look it up, it's a plus 3. When we look up fluorine, it's a minus 1. So we have to have 3 fluorines for every aluminum. And so we're getting back to writing our formulas that was so important at the beginning of the semester. You know, use these all the time. So plus Al F3. Okay. Then it forms aluminum chloride. So aluminum again is still a plus 3, and chlorine's a minus 1. So we're going to have 3 of those. So it'd be Al Cl3 plus fluorine gas. So how should I represent fluorine gas? F2. Then at this point in time, I balance it. So if you were gone yesterday, a couple of you were gone yesterday, we balanced equations. And one way we did that, and I didn't leave you much room on the balancing sheet to do this, but one way we did that is we kind of had an accounting system. And off to the left, I'll show the ones on the left side. So I don't have much room down here, so I'm going to write CL, and I'm going to write AL, I'm going to write F. Later on, I told you you didn't have to use this all the time, and I know a lot of you aren't going to. So on the other side, I'll write CL, AL, F. And then I'll count how many I have. So CL I have 2, AL I have 1, and F I have 3. On the left side, I have 3, 1, 2. So the chlorines I've got to get to what value? Total, 6. I got to get 6 chlorines because a 2 and a 3 subscripts, the only way we can have those equal out would be if I get both of them to 6. So I'm going to put a 3 in front of this. That's a multiplier, and that gives us 6. Okay? Then over here, I'm going to do the same thing with the AL, and I'm going to put a 2 in front of it. Okay? So I'll put a 2 in front of this. When I do that, it multiplies this by 2, gives me 6, and it multiplies my aluminum by 2, and it gives me 2. So then what do I need to balance out? The F's. I do that by taking this times 2 to get 6 fluorines. It also gives me 2 aluminums. And then what do I have to do in front of the F2? Put a 3. It gives me 6. So now everything balances. 6, 2, 6, 6, 2, 6. Got everything. So the balance equation that you get for that written equation is 3Cl2 plus 2AlF3 gives you 2AlCl3 plus 3F2. So I'm going to let you guys have the opportunity to do one of these examples, okay? And what we have to realize, we're going to have an H in front, right? Where do you look to find the chloric? Where does that come from? Doesn't come from the polyatomic ion sheet because it's binary, right? Chloric would come from there, but if it's hydro, it's binary. So it's H and what? Cl. The charge is balanced. H is a +1 and chlorine is a -1. So there's hydrochloric acid. Okay, so HCl. So go ahead. The rest should be pretty easy. So go ahead and put in the rest. Need a balance. So hydrochloric acid plus iron metal produces hydrogen gas plus iron-free chloride. And then you just have to balance. This will be a good one to practice because you're going to find out that it's going to be not easy to balance because here's a key. Remember, if it has something that has a 2 subscript, that means it can only be even numbers on the right side. So hydrogen can only be 2, 4, 6, 8, 10, 12, going on up. It can't be anything but an even number. If I put a 3 in front of this, it makes an odd number of hydrogens to balance out the chlorine. And that's not going to work. So what am I going to have to do in front of this in which to get the hydrogens to balance? I'm going to use a 6. I'm not going to use a 3 because my hydrogen won't balance. So I'm going to take an even number that I can get 6 chlorines, and so I'm going to put a 6 here, and then I can put what in front of hydrogens to balance out my hydrogens? The 3. Okay, and then in front of FeCl3, what am I going to put? A 2, and then the iron would be 2. So 6, 2, 3, 2. Okay? You have to pick up on those things to help yourself out. If you keep in thought, anything I put in front of something that's diatomic, I'm only going to get even numbers, and I start making odd numbers on the left side, it's not going to work. So you got to maybe sometimes you multiply, double something, and then when you do that, then the even numbers kind of come out. Work. Okay, let's work through just a couple problems on your sheet, and then I'll let you have the rest of the time to work on that and finish it up. Let's take a look on your sheet. Let's take a look at, let's do 6. Okay, let's do number 6 on your sheet. I'll see if I can fit it in up here. I picked this one because this is a pretty tough one to do. Okay, it looks really intimidating, but we have to realize that PO4 is on both sides, so we're not going to split PO4 up. Realize that NO3 is on both sides, and we're not going to split those up. Do not split them into oxygen, phosphorus, okay, when you do that. So I'm going to do it by site, not list everything out. You guys don't have a lot of room. You could always do this on a separate sheet if you want to list them out, because I didn't give you much time or much space. So does Li's balance? The lithiums, are they the same on both sides? Okay, one of each. We're okay. How about PO4? Are they the same on both sides? No. So I have one PO4 here, and I've got 2 PO4s over there. So what should I put in front of this one? Yes?
On our sheet, it has Li3PO4.
Oh, okay. Then that messes things up. So we do have to balance the lithium. So what do we do to balance lithiums? Let's put a 3 here. Okay? PO4s. There's 2 there, so what do I need to do to balance out the PO4s? Put a 2 in front of this? Does that make sense?
Doesn't that mess up the
It does. And so sometimes when you start, there's some things you'll have to go through and change because it's not going to work out perfectly like you would like. So I'm going to put a 2 in front of this to get the PO4s to balance. Everybody see that the PO4 is balanced.
And then you can change the 3 to a 6.
Right. Then what I can do is go, okay, I can go ahead and then take this 3 and get rid of it and put in a 6 to do that. Now both of those balance, right? Li 6, PO4 2. Hopefully it goes smooth now. Zn, what would I put in front of this? 3. Zn's equal. This is where students mess up. This 3 multiplies by that 2. So 3 times 2, 6 nitrates. How many do I have on the right side? 6. Okay, I'm not splitting them apart. I'm doing them, and sometimes like on the lithium, we just have to go back and change it. It's not a huge thing. All right, so I'm going to give you opportunity to work through this worksheet, and we'll go through it tomorrow. Okay? And I'll come around as you guys have questions.